All right, welcome everybody to another stream. Today we have an exciting one. We're going to be talking about Rust once again. I've been off for a couple of weeks, and before that was talking more about things like ELF and binary formats and stuff. So check out my YouTube channel if you want to see more about that. But today we're back doing some Rust programming. Specifically, we're going to pick up from a previous stream before where we talked a little bit about FFI, and we're going to be actually doing a real FFI project this time around. And so the goal for today is to be creating not a whole project, but to get one scaffolded. And depending on how people like it, we can go ahead and see if we actually make a series out of this and hopefully even get it to a usable state. So Chad is asking what mic I'm using. It's Blue Yeti, I think it is. I can't remember the model number, but it works fine. I don't. I'm not an audiovisual guru here, so I can't really say exactly what the best setup is. But hopefully mine sounds and looks okay. All right, so what are we actually going to be working on today? Let's answer that question. Real quick, I'm going to pop over to this screen here where you can see Microsoft Flight Simulator 2020 for those who are not familiar with MSFS 2020. It is a flight simulator game, or I think hardcore simmers would prefer it to not be called a game, but a simulation where you can fly airplanes, various kinds of airplanes, all the way from propeller airplanes to jumbo jets across the world. And MSFS 2020 simulates the entire world, so you can fly literally anywhere. And it's using like Bing Maps data to basically create to a fairly high level of fidelity the entire world, and some cities are incredibly high level of fidelity. So I've been playing this a whole bunch lately, been learning about aviation, which has been fun for me and good for me because I don't actually like to fly, even though I do it quite a bit. So being in control in the pilot seat has taught me a lot about what potentially is happening when you're hitting turbulence and stuff like that. So it's been educational on that front, and also just flying around the world is cool. So that's been a lot of fun. But Microsoft Flight Simulator 2020, which is a mouthful to say, and I think I'll just call it Flight Simulator from now on, or the sim. It comes with an SDK as well, so you can actually programmatically hook into the game and change the game. And that's what we're going to be looking at today, is creating bindings to that SDK to Rust. And if I understand correctly, the SDK exposes itself through a C API, and there's also a C# API that you can hook into. But because there is a C API, we should be relatively easily be able to, I'm knocking on wood here, relatively easily be able to hook into it from Rust and be able to actually call into it from Rust. So before we get started, let's hop over here. There's a couple of projects that I haven't done a ton of coding on this beforehand, but did look around at a couple of projects just to get familiar with what's going on. This is an interesting project here in terms of what you can use this SDK for. It's called GEES, I guess, and it's a in-game landing analysis. So you run this next to your game, and when you land in the game, it provides an icon for you, and it can give you certain stats on your landing and stuff like that, so you can know certain things about your landing and presumably like how well you do with your landing. So you can see here what's measured: descent rates, g-force, airspeed, and stuff like that. So this is an interesting project, and the hope is that we will be able to build this SDK and eventually be able to create a project similar to this in Rust. Of course, this has a GUI element to it as well, and Windows GUI programming in Rust is possible, but is not trivial or as easy as it is in C# so far. But theoretically, this should be possible to do in Rust as well. Now, the C#, this project takes advantage of FS Connect, which is a C# kind of SDK that wraps the kind of base SDK and provides some conveniences on top of it. So I thought that was interesting. But underneath this is the SDK that's provided by Microsoft for the flight simulator. And it's exposing a C# API, like a managed garbage collected API, which I don't think we want to hook into. We instead want to hook into the C, or it technically, I think, is a C++ API, but it exposes itself. It doesn't really use a ton of C++ features. There is some light inheritance that we should be able to mimic on the Rust side. And I found this example here. Now, the interesting or not so interesting thing about this is that this SDK is called SimConnect, and apparently the SDK exists from way back previous versions of Flight Simulator, and like Microsoft Flight Simulator 2020 implements this SDK mostly, but not entirely. And so all of there's not a ton of examples online of things specifically for the 2020 version, but and to be perfectly honest, there's not a ton of documentation on previous versions either. But if we do find things that reference old versions of the SimConnect API, it should work in the newest version. At least I'm hoping. And that seems to be how other people are doing it. And so here is a small C++, or really, I mean, it says C++, but it's basically C, code using the SimConnect API. And my hope for today is that we can get through and basically copy this in Rust code. So we'll be able to do what this is doing. And basically what it's doing is it's connecting to the SimConnect API, and then it does some mapping between events, so that it gets notified on certain events in the game, because by default you don't get notified of anything. It does some mapping in terms of inputs, and so up here it maps this brakes event. Presumably when you hit the brakes on your plane, you'll get notified of it, and does some things around notification groups and priority of notification. And then it maps a certain key binding, presumably Shift Control U, to a certain event, in this case brakes. And then it gets this dispatched callback basically for all of the events. So my dispatch proc1 gets called with different events, and you can see here that this is where it's handling it. It's looking at a certain ID and saying, okay, this is an event, doing some light casting and saying what type of event is it, and then if it's the event breaks, then it can do a certain thing. And in this case, it's just printing out we got some breaks, which is not too exciting, but you can presumably do more with that, and we can kind of dive in and see what's happening there. By default, it's doing nothing. And it also gets an event on quitting and mutates a global variable called quit here, which it's constantly looking at and saying, is it quitting? If it's in the quit state, then break out of it and then close the thing down. And that's it. So this is running as a separate executable, separate from the game, and basically hooking into the game as it's running. And so the hope for today is to be able to to recreate this. And here we have a bunch of documentation, which I hope all makes sense in terms of this. Again, I haven't really done a ton with this except for kind of read through some of this stuff and try and understand what's happening here. So hopefully we don't get stuck too much. In general, the thing that we're going to be trying to do to recreate this is create a new project. We're going to use bindgen to hook into the SDK, which I've already downloaded on my machine, and I'll show you how to do that in a second. The SDK comes with very, very light documentation, not nearly as good as this, or as detailed as this seems to be. I'm hoping it's good. But it does come with a header file for the SDK, and so we can use that header file to generate Rust bindings, and then we should be able to recreate this, hopefully. All right, any questions from chat, let me know. Otherwise, we're just going to get started, and I'm going to switch over to this view here. I presume that you can see my mouse and stuff like that. Chat, let me know if that's not the case. And the first thing that if you want to follow along, what you need to do is, of course, you need to have a copy of the game. If you don't have a copy of the game, you have to buy one. It's like $60 or whatever. And I'm using the version that's from the Microsoft store. And I have like an Xbox Live subscription that gives me this. It's a really good deal. So to download the SDK, you have to go into options, I believe, general, was it? Yeah, developers, and turn the developer mode on. And with the developer mode on, you get this developer menu up top, at the very top here. I'm at the top of the screen here. And inside of here in help, there's downloads, and you hit the SDK installer, and you have to install the SDK here. There's some tutorials, which to be fair, I have not looked at, and samples as well. But you download the thing here, and then of course you get the SDK documentation as well here. So let's open that up, and I have to switch back here. Here is the documentation page, and it says like here's the release, and here's some changes that we did and stuff like that. SimConnect documentation updates for static libraries. That's roughly what we're going to do. Maybe I haven't seen that. We'll see. And I know down here is like SimConnect that they have here. Yeah, so this section of the documentation is still a work in progress, very much so. Apparently you can compile this and run in process inside of the game as a WebAssembly module. I haven't figured out how to do that, and I haven't necessarily thought about what the advantages or disadvantages of that is. Chat, by the way, apparently my internet is not doing too good, so let me know if the frame rate is being dropped. I hope it's still viewable. So apparently you can run this as WebAssembly modules. I have not figured out how to do that yet, or what the advantages of it. And in terms of like what is supported, apparently like weather functions, so hooking into the weather system is deprecated because the underlying weather system from the previous version of Microsoft Flight Simulator has changed radically, and so you can't use that. And so all I've found is like they have like status of certain functions, like what works, what's been verified to work, and what's been verified to not work, and what's not been checked yet. And so we can see here, hopefully everything that we do today works. I checked to make sure that everything that we want to do today, I believe, should work. And so we hopefully won't run into too many bad situations there. All right. Okay, so I guess there's no questions coming from chat. I hope chat is still there, but because I'm apparently dropping frames right and left, so sorry about that. But chat, please make sure to give me a thumbs up just so that I know that everything's still working fine. And without further ado, then we can go ahead and get started. This is on Windows, right? So we're going to have to do everything in Windows, and I'm going to be using PowerShell to do that. And so real quick, what I want to do is run cargo new, and we can call this MSFS 2020. I think that's a good name. And we want this to be, we want it to be a binary, because we're eventually going to turn this into a library as well. But for now, we want to run it as an actual executable so that it can run next to the game and actually do something in the game. All right. So hopefully everybody can see that, and we can expand this out a little bit here. If you're new to Rust, by the way, and this is like one of your first streams or something that you're catching here, we're not going to be doing beginning Rust here. This is actually I don't want to say very, very advanced stuff, but FFI and unsafe, which we're going to be doing today, is definitely reaching into the more advanced category. And so, don't hesitate to ask questions if you don't understand something, but do recognize that this is not going to be kind of super beginner-friendly material that we have here. Thick Logic is saying that the stream is running fine, so thank you, chat, for that. I appreciate it. All right. Okay, so what are we going to do here? We have our main function. Let's just go ahead and I'm going to expand this out a little bit. Let's just go ahead and run that real quick, just so we've got that going. Cool. So we were printing out hello world. So the first thing really that I think we need to get working is to actually create our bindings into the SDK. Now, how do we do that? Well, we're going to be using bindgen for that. So let's take a look at the bindgen documentation here. And what bindgen does is takes a look at a header file, a C header file, and interprets it and spits out Rust code that is equivalent to that C header file. And so the first thing that we want to do is add bindgen as a build dependency, since we're going to be doing this at build time. So we're going down here, add it as a build dependency. I don't think that that's actually the latest version. It's not. Cool, we can just do this. All right, so we have bindgen as a build dependency, and then we want to create a build.rs build script, and this gets run automatically on build. If you've not done build scripts before, they basically just are little executables that get run by the compiler or by cargo automatically when you're building your project, kind of as a hook into the build process. And it says we want to create a wrapper.h header here, where we will actually include the header file and any of its dependencies when we build it. So wrapper.h, this is going to be the header file that our project generates. And we need to then include the Flight Simulator SDK header file. Now, where is that? Is a very, very good question. Let's not open that up. We should be looking in, I believe it's in C, and I'll do this in quotes so that it doesn't get all messed up. Inside of the C drive, and I believe, if I remember, I looked at this yesterday. Yeah, there it is. MSFS SDK is installed there. And then here's the actual SDK folder, and then there's an include directory, and there it is. So that's our header file right there. symconnect.h. So we can basically just steal this and paste it in here. And I hope, oh, what happened there? Somehow it got all messed up here. And let's see. So it's saying it can't open it. I'm wondering if that's because these need to be escaped. I mean, it's true that it's not in our include path, but it's an absolute path. So I would expect it to work. Let's see. Oh, there it was. Okay, it was just that space. Cool. So yeah, we're including that header file now, like we did before. So that's good. And then in our build file, we're basically just gonna like copy all this stuff here. We can literally just copy this here, and we can go through it in here. So we don't need two main functions, of course. So tell cargo to tell Rusty to link to the system that we don't need. Tell cargo to invalidate the built crate whenever the wrapper has changed, presumably. Let's go ahead and close this. Yeah, whenever the wrapper changes. So this basically is a directive to cargo to say, hey, don't rerun this unless wrapper.h changes, which makes sense. We don't need to rerun our bindings every time we build the project, only if our wrapper.h actually changes, which is cool. Oh, and it looks like chat was catching my mistake before me. That's always the best part about streaming things, is you have people who can tell you that you're being silly and missing something. All right, so the bindgen builder is main entry point, blah, blah, blah. So we get a builder here. We tell it that our header is wrapper.h. These are some callbacks, basically. We just want the default callbacks that we have here. Finish the builder and generate the bindings. Cool. We'll just explode if it doesn't work. And then we are putting those bindings inside of this out directory, which is a thing that cargo sets for us. And this is just best practice of where to put generated stuff. So there's this out directory, and then we put the bindings that we've generated inside of bindings.rs. So let's give this a try and see what happens. Cargo build. Whole lot of errors. Okay, what do we have here? It's saying that it doesn't know about dword, which is true. And you know what? Let's open this as well, just to take a look at it. Cool. So here is the header file that the SDK comes with, and it's already complaining a bunch because it doesn't know about dword. It has some other stuff that it doesn't know about. Interesting. Dword is only a thing on Windows, I believe, and so. We could put in, like, up here a definition for dword, but I'm going to try and just do all of windows.h, and we'll see what happens. And so this is just the Windows kind of default header file that includes a bunch of Windows specific stuff, and most things on Windows will depend on that. And let's see what happens there. Expected identifier or brace on line 384 here. 384. Okay, here's a sim connect ref struct, and I can already see that this is inheritance that's happening here. And so this looks like this is, I mean, here sim connect.h is a header file, but this is actually C++ here. And bindgen, I believe, if I remember correctly, differentiates between C and C++ by the fact that the header file, if it's a .h file, it will assume that it's C, and if it's .hpp, then it will assume that it's C++. The sim_connect header file here is labeled as .h, and so bindgen will assume that it's C here, but it's not C, it's C++. And so we have to tell bindgen, hey, this is C++. And I cannot remember how to do that. Oh no, that's not what we want. We want the documentation. Where can I wish that they would just give me the documentation, a link to the documentation in here, bindgen Rust, or we can just do crates.io, bindgen. Oh, it looks like I have a subscriber, but I've missed you, whoever you were. Oh, Cylind Z, thank you very much for following. I appreciate it. All right. So we're here in bindgen. We got our documentation here, and what we're looking for is something on this builder here that allows us to say, hey, this is not, this is C++, C++, header, enable CXX namespaces. That's not quite right. What was it? There's something here that allows us to let's see here. Clang args. This could be a possibility here, that we can just pass something to Clang to let it know that it's C++. By the way, bindgen is using libclang as well, and so if you've not used bindgen, which I have used bindgen on this computer before for other projects and stuff, and so if you have not done that before and you're on Windows does not come with Clang by default, and so you have to install it through all of the Visual Studio shenanigans that there is, which can be Visual Studio's installer is very much geared towards you having Visual Studio as your IDE and not having VS Code, or at least as far as I can tell. And so it took me a little while I remember the first time that I did this to get libclang actually installed up and running on Windows, but it's certainly possible to do. Oh, and there's a question in the chat about extern crate bindgen and why I didn't copy that in right here. This used to be necessary in Rust 2015 edition, but it's no longer necessary in Rust 2018, which when you create a new project with Cargo since 2018, so 2 years now, this is not necessary. You can put it there, it won't do anything. It's completely fine to have this, but you don't need it, and so I just didn't copy it, that's all. Yeah, so I believe the thing to do is to add a Clang arg here, and I can't remember Clang force yeah, here it is, -xc++. And so we should be able to do something. I'm going to get rid of these comments because I don't feel like they're actually helping us here. This is not meant to be a tutorial. So .clang arg. And I want to say that might work. We'll see. Okay, that did something. So thread main panicked, libclang error. I wonder, unrecognized flags. Okay, so that maybe didn't work. Let's try it with this, where we give each individually. Here. And this needs to be an iterator, which arrays are not iterators, but references to arrays are. Cargo build, and we'll see if this works. My Rust analyzer is taking a longer time now, so that's good news. Let's hope that that means that it's actually working. And if it does work, what we should end up with in our target directory here, inside of this build folder here in MFS 2020, no, it's this one. This is the out directory, and that's what this outdir refers to, is this directory right here. So we should be writing to bindings.r, and when this finishes down below, there it is. Yeah, there it is. Cool. So that is a lot of code, because this is going through and not only compiling our code, but also all of windows.h, and that ends up being here, oh geez, 285,000 lines of code, which is actually not that bad considering that windows.h is huge. But it is definitely quite big, and much bigger than what we need to. I've run into this issue before, and I remember that the way that I was handling it was by using this whitelist functionality that they have here. And so we can actually add to an allow list for what types and functions and other things that we want in order to not have to compile all of this code. So we might want to do that instead. But the first thing that we need to know is what functions do we actually need. And if we come up here to our example, and remember this is the example that we want to recreate here. Of course, here's our main function. Blah blah blah, test input and events, and then for those that don't know Windows programming, H results are the typical return values from kind of Win32 APIs, and they're just numbers. They're I think 32-bit signed integers that indicate some kind of result, usually with 0 being success and then non-zero values being some kind of error value. And succeeded is a macro that simply decides whether the H result is a success value or not. And the first thing that we're doing is calling SymConnect open, which presumably goes ahead and connects us into this SDK and connects us with the game that we have. And so I think that's the first thing that we're going to do, or first thing that we're going to need. And so let's go ahead and call this allow list functionality here, whitelist function, and it is SymConnect open. And this will be interesting to see if our bindings file shrinks at all because of this. It's still running, and hopefully what we'll end up with is a much smaller, much smaller bindings that we have here. So we went from 250,000 or whatever that we had to 46. So definitely a good move to do this. And bindgen, I believe, does a good job of kind of tracing back all dependencies that you have. but so this will still work and stuff like that. We even have some Windows.h definitions here. So this stuff comes from Windows.h, dword, char, lpc star, stuff like that. Which is, it's nice that we have this here so we can see what they actually are in terms of Rust Rust definitions. And so SymConnect open is going to take this handle, whatever that is. It's going to take a sc name as a lpc stir, which I think stands for long pointer C string. Takes an hwind, user event 132, don't know what that is, event handle, config index, and stuff like that. We can see what are being passed in here, and it looks like for most of the stuff they're just passing in null or zero, so we don't have to worry too much about it. So now that we have this, we actually need to bring this into our own code, and the way that we do that is depending on your definition of beautiful, either beautiful or horrifying. And we do that by doing this, where we basically use this include functionality, which include is just saying, like, literally take the bytes that you find at this path and like plop them down into this file and treat them as Rust code, whatever it is. And so we are concatenating together whatever is inside of our outdir environment variable, which is a path to this file here, and concatenating that with /bindings.rs. And then we're including that directly into our file, which we can do in here. Let's collapse everything in source, and we can just for now say that this is bindings.rs. We can move this around a little bit if we don't want to have it here long term. And of course we need in Rust does not follow your file system to find out where modules are. You actually have to declare them, and so we declare our bindings module, and now this is going to actually be included in our project. And so with that, my hope is if we do bindings, and there it is, SymConnect open. Cool. Great. So we hopefully should be able to connect with SymConnect open here, and this is going to give us an H result again, and we can just say, like, instead of printline hello world, we can just do like opening and print out this HR, and I like to do that as a hex, because most of the time when you view the documentation about H results, they're viewed in hexadecimal notation. Cool. And in fact, most of the time they are viewed as unsigned 32-bit integers. Great. Okay, so now we actually need to call in this. I'm going to collapse this here. So if we look at the code that we're trying to actually mimic here, the thing that we're trying to do is this hSymConnect is some kind of handle. Yeah, and here they're doing it as a global variable. This is very common. I'm not a Windows programming expert whatsoever, but I have started to do some Windows programming. So some of this is kind of becoming natural to me. But if you've not done Windows programming before, this may seem, and especially, I mean, some of this is also similar to how just C programming in general is. So if you've done some C, even only on Linux or something like that, this should seem familiar to you. But if you've not done C programming before, then this may be a bit weird. But this is quite common, where we have some pointer that is null originally up here, and we are passing in as an out parameter that to some kind of constructor function here, and from that we will get a hopefully non-null pointer to some handle, which is just like an opaque pointer to some thing in memory, and that thing gets passed to every single function that we call, and is kind of like the context to the SDK that we have created. And Dennis is saying, reminds me old stuff from my 132 programming back in the days. Yeah, this is effectively 132 programming here that we're doing. Cool. So we need to have a handle, and we should mark it as mute because we're going to mutate it. And we started out as standard pointer not here, and we're going to pass in that handle, a mutable pointer to that handle. And this of course is going to be unsafe. I think that's what it's complaining about right now. And in fact, I don't like to do this in real code, but for now, just for now, since everything we're doing is unsafe, I'm just going to wrap literally everything in unsafe. At some point, we'll clean that up so that not everything is wrapped unsafe, which I think is definitely a code smell. Like, you don't want to actually wrap everything in unsafe, because that kind of defeats the purpose of unsafe. Okay, and so we pass in this sc name. I don't know what sc name stands for, but let's look in this documentation to see if we're actually getting information that we need from it. Cool. Okay, so here is our SimConnect open. Pointer to the handle that we already had, and then sc name is a pointer to a null terminated string containing an appropriate name for the client program. And the empty string is valid. Null is not supported. Okay. We got another follower in Curbiskern. Thank you very much. I appreciate it. Cool. So we need a null terminated, a pointer to a null terminated string. How do we do that? Well, there's a whole bunch of ways, but one way that I like to do it is by first starting with a byte string. So you can do a byte literal like this. And let's call this example here. And you can see from this right here is Rust Analyzer kind of plopping in the type for us so that we can see it. It is an array, a reference to an array of U8s here. And that's good because references are essentially pointers with added guarantees to them. So we can treat this as a pointer. So we should, and of course we need to not forget our null terminated thing here, because this is a C string. Rust does not have null terminated strings by default. Rust strings are not null terminated. And so when we need a null terminated thing, we have to remember to put it in there. And then we can, let's pass this in like this and see what it says, because that's always illustrative. And it says, hey, I'm expecting a pointer to I8, and you gave me a reference to an array of 8 U8s. And so we should here be able to say, cast this as a const. Now, we might be tempted to do something like this, but this won't work. It's saying like, hey, I expected a U8, but I found an I8, and that's referring to what this thing is pointing to. So we can do this, but this down here will still complain and say, hey, I want a pointer to signed 8-bit integers, and you're giving me a pointer to unsigned 8-bit integers. Well, signed and unsigned 8-bit integers at the end of the day are the same thing, just how you think about them. And so we can just cast again, and this should work just fine. Cool. So now we have our name here, and if we look back at our example here with SimConnect open, we have the handle, which we've done. We've had the name, which we've done. Now everything else is just null and then 0, 0, 0. So we can do the same thing here and just do standard pointer. I wish this would. I don't know why this isn't wrapping. Probably when it compiles, it will wrap. And I think this has to be a null mute. This can be 0. This can be 0. And this can be 0. What is complaining about here? Come on. Interesting. Expected raw pointer. So apparently, D word. Oh, handle. So this this is also supposed to be null, even though 0 and null on Windows are the same thing. So this would technically work. It's really a pointer, and so we got to do it like that. Finally, it wraps. All right, cool. Let me know if there are any questions about this. This is essentially what we're going to be doing for the rest of the day, is kind of translating in our heads and with the help of bindgen the C functions as Rust code. But hopefully this is not too confusing. But if it is, please do let me know. And let's see when we run this if we actually get if we get a positive result here. Ho! Okay, we've got a linker error of some sort, which is never good. So linking with link.exe failed with some unresolved symbols. Unresolved external symbols, sim connect. Okay, yes. So we are referencing this sim connect open function, but like, where is that coming from? That doesn't exist in our program. We didn't write that code. That exists presumably in the SDK library, but where is that library, and how do we actually tell the linker, like, hey, you can look over here for that library? And there's multiple ways to do that, and in this case what we're actually doing, and what we do by default here, is we're dynamically linking to this this SDK library, which on Windows dynamically loaded libraries are DLLs, dynamic loaded libraries. And so we basically need some way to tell the linker, like, this is where you can find the DLL. And I've already found the DLL. Kib3T, thank you very much. Kibit, appreciate it for the follow. We already found the header file here, right? And it's very common in C projects next to an include folder for there to also be a lib folder. And there is some managed code here, so that's presumably the C# library, but there's also the SimConnect DLL as well. So that's the DLL that we want to dynamically link to. And there's a whole bunch of ways that we can actually get this to work. The easiest way, though, is on Windows, when you are dynamically linking a library, there's a certain order of places that the dynamic linker looks for those libraries. And the very first place that it looks, and this is not the same as Linux, the very first place that it looks is the directory where the executable that you're running is. So the current directory of the executable, which for us, our executable lives inside of target debug here. This is our executable, msfs2020.exe. And so we want our DLL to be next to this exe file. And so what we can do is just go ahead and copy this, and that's a good cheap way to do this for now, into our target debug folder. And so now the DLL is, simconnect.dll is right here, and the exe file that we're actually running is right next to it. And so I hope this works. No, it doesn't. All right, so we need some way still of, I think what we need is to also tell the linker that the symbol SimConnect open is related to that DLL, belongs to that DLL, and I'm forgetting how we do that. So we might have to go to the Googles here, or DuckDuckGo, Windows linker, associate Well, oh, what was it? Here's a whole bunch of stuff about the linker, which should be very interesting to read about. Windows DLLs. Yeah. Yeah, there are these .lib files which basically expose the symbols for a given DLL. I don't know if there's a .lib here as well. We could try copying that over and seeing if that helps. But I think that we will have to say, we'll somehow have to say that this .lib, we'll have to tell the linker that this is the lib file, and you can see that they're doing that for some kind of base libraries here. And I always forget about this. I think, yeah, here it is. Cool. So this is, real quick, the reason that I knew to look here, this is the build documentation about the build scripts that we're using. We're using a build script right here. And we've already used a directive here with this print line to tell Cargo, hey Cargo, only rerun this build script if wrapper.h has changed. And also Cargo will rerun the build script if the build script itself changes. But otherwise it doesn't. And there are other directives that you can tell the build script to do other things. And one of them is this one. Rust link lib. So the Rust link lib instruction tells Cargo to link the given library using the compiler's L flag. So I'm pretty sure this is what we need here. We need to do exactly this, but instead of this, whoops, we say we want to link with this lib, and the lib is called sim connect.lib, and we didn't do it. Just to make it easier, we should be able to copy that in here, and I'm pretty sure that the linker will look in that folder. Unknown library kind. Oh, we had a typo there. Okay, this is looking better. And Siri was saying in chat about the double equals that I just had in that line. Thank you very much for that. Oh yeah, and we don't want to have .lib because .lib is assumed and gets concatenated automatically. Yeah, so the .lib file, again, to just repeat what this was, the .lib file cannot open input file .lib. It's not finding it. I wonder if we put the full path here, pwd, yeah. If we put this as an absolute path here, Shimnai, thank you very much for the follow. I appreciate it. And then we want target debug. I'm just going to put they're putting the full path here, so that it knows exactly where to look. And I have to since Windows uses forward slashes for paths, we have to escape that with this raw string syntax, which basically says between this hash until you find another hash, everything just treated as like literal characters. So we don't have to escape every one of them. All right. Renaming of the library C was specified. I'm following the stream under things I'd never thought I'd see at Microsoft. I'm curious what you mean by that. That's and VM the Hut, thank you for streaming, Ryan. I learned something new on every one of them, no exception. I appreciate that. I also learned something new on every one, so that's good. We're learning together. I'm interested what this error is all about. It's saying renaming of the library C was specified. What? However, this crate contains no link attribute referencing this library. Is it treating that as the name of the library here? It probably is. I wonder if I wrap this as well. This is probably horribly broken, but we'll see if that helps. Yeah, I'm thinking it thinks that this is a library here. And that didn't seem to help. Let us, because there's also this Rust C link search, which instructs Cargo to pass the capital L flag to the compiler to add a directory to the library search. So this is instructing it where to look for our symconnect lib. Let's try that. So I'm just going to call this symconnect. And Rust C link search. But we also need a way of specifying a full path. I hope this doesn't screw things up. This is the fun of having, C code with interesting linkers and compilers and stuff like that. You run into this kind of thing. So we want to reference this here. And we don't need to reference the actual lib itself. We'll see. Hopefully this... We just need a way to say, hey, this is the library. Oh, gosh. Okay, that seems to work. So we said, look for the lib, and this, it has its own places that it looks, but in addition to those places, look inside of this directory here. We're going to link against symconnect as a library. And symconnect has a mapping between these, or has like a way of saying these are the symbols that this library supports, and it knows where to find the DLL then. And so we should be able to run it now. Amazing. Cool. So it's not doing too much right now, but effectively what we've done is we have run this code and we've printed out our HR result, and the HR result is 0x0, which is a very good sign because, unless I'm horribly mistaken, 0 is success. So we'll continue with that assumption, but I think we're doing pretty well here that we have 0 as a success coming from symconnect open. And let us celebrate by doing the correct thing here. And there is a symconnect close. This is a function used to request the communication with the server is ended. And I think that that's a proper thing for us to do here, is actually request that we close the connection to the server at the end here. And so we need to go back into our build.rs here and call this functionality here to actually generate bindings for symconnect close. And hopefully when that finishes, we should see symconnect close down here. Come on, come on, come on. And chat is saying, smells like a drop impl, and I absolutely agree. We'll be doing that in just a second. So great, this is symconnect close here. That looks wonderful. We want to use symconnect close, so we're going to say bindings symconnect close, and it expects the handle that we had from before to be passed in. And let's just go ahead and say closing. And we'll do just like this before. So now we're being good citizens here and closing down our connection. And just like chat said before, let's close others. Today we're just trying to get something kind of hacked in here, but I think we can start a little bit moving towards eventually having a library that makes this easy to use, where we don't have unsafe all over the place. And I think that the best way to do that is by having some kind of struct that we can call like symconnect, and inside of that we can have a handle, and we'll say that this is going to be a standard pointer. We can do non-null here. We might want to do that, and it's going to be to cvoid, and we need to include cvoid here, use standard FFI, GGI, FFI, cvoid. And then inside of symconnect, we can do new here, and maybe now we'll do that in just a second. And we will return a, now Clippy complains when you do a new function called that returns a result instead of just the thing. I don't like that, so I'm gonna go in the face of Clippy today. Sorry, Clippy. We're gonna call it new and return a result here, and then return an H result. I wonder, bindings H result? Yeah. Cool. And so we can effectively just copy this out. And now, down here, we will say if HR is not equal to 0, then we return an error with 0. Otherwise, we return OK with our self and the handle that we had. And what we need to do is standard pointer non-null new handle. And non-null is basically expecting it to be non-null. We also expect it to be non-null, but we're going to check it just to like be super certain. Symconnect open returned non-null pointer on success, which that should never happen. If that happens, then there's something mega wrong going on. So it's fine to crash the program there. And of course we need some unsafe going on here. And here we'll just wrap this this thing here an unsafe, so we know exactly where the unsafe is happening. Let's go ahead and this isn't strictly necessary for now, but we can make these pub for now. And this is looking good. So then we can get rid of all this stuff here and just say symconnect new. Could not create handle to symconnect. All right. Error error 0. Yeah. Thank you, chat. Chat found this. I was returning error 0. That's not good. So this is correct. And presumably, what we want to do is take in like name here. For now, we can just take this in as a, well, let's take it in as a string, as an owned capital S string. And with the string, what we can do is, the whole question though is this pointer supposed to last? Who is responsible for this memory? Because right now we're passing in a static pointer, so this pointer is always going to be valid. Let's punt on that for now. Actually, let's not. This is a good teaching moment. Chat is saying a null pointer on success. Yes, sorry. The error condition is that symconnect open returned a null pointer on success, which is unexpected. That is true. Thank you. Cool. Okay, so we wanna replace this with something that the user passes in. We can, of course, just take in like this and hope that the user has passed in a string that ends in a null, null terminated. We can also here do docs.rs. The standard library comes with a C string type, or C. Let's even do C stir here. And this represents a borrowed C string. So this type represents a borrowed reference to a null string. So this should be as pointer. This should be fine. We basically want this. So we can take the in here a C string here. And this will indicate to the callers of this library that they need to pass in a C string, a null terminated string to us. So standard, we can just do, is it in FFI? Yeah. We can just do this. And then here, that should work. Great. I went kind of fast through that. Hopefully you understood what was happening there, but let me know, chat, if you have any questions about that. We're essentially enforcing on the callers of this API to pass this a C stir, null terminated string, instead of, if we did ampersand stir str, then they could pass in something that wasn't null terminated, and then we might have problems, which we don't want. And in order to create a C stir, we should, what is the best way to create a C-stir? I guess this. So we also need C-string. C-string new. And I'm hoping that it will dereference. No, it won't. How can I? I need a way of getting it as a C string. How can I do that as C string? There we go. That helps. What is it? As because new creates a new C-compatible string. This function will consume the provided data and use the underlying bytes to construct a new string, ensuring that there is a trailing 0 byte. This trailing 0 byte will be appended by this function. The provided data should not contain any 0 bytes in it. So the errors are the function will return an error if the supplied bytes contain an internal 0 byte. Okay, which example does not. So we can feel safe to unwrap this. Cool. Great. And so the last thing that we need to do is implement this kind of the pattern where it's the RAII pattern where we essentially drop on drop we clean up after ourselves. So we can implement drop here for SimConnect. And inside of the drop function, let me scroll down here, we just do this. And you know, we won't look at the H result. If it doesn't succeed, it doesn't succeed, that's fine. And handle is, of course, self.handle. And this is now a non-null pointer, so we have to convert it to the nullable pointer type. And this is no longer unsafe in main. Cool. So now we've effectively made a safe API for this code, which is great. And so now, like, assume this is all internal to a library, and then users of this will just call this, and this is all completely safe code. And there's nothing they can really do wrong here, because we're ensuring, for instance, that they're passing into C string and stuff like that. And so this is all really great. Cool. How are we doing on time? Cool. We got a little bit more time. I think I'm going to go for another about 40 minutes or so. So Wendeliu, thank you very much for the follow. I appreciate it. And if anybody else wants to see me butcher their name, then feel free to follow. I appreciate each and every one of you. Yeah, chat, let me know how things are going with you, if everything seems pretty reasonable so far. I think what we're going to do now is go ahead and go further with our example here. So we basically have done this now. Of course, we're not printing. If we fail to connect, we're just crashing with this expect here, but that's also fine. And it should be fine, for instance. So this is an interesting thing. This is very interesting for FFI, where you have to think about these things. When we call SimConnect new here, we have to make when you're doing FFI code, you have to make sure that like your calls here to unsafe are always going to be in a way that you expect. And so we call drop on SimConnect here we need to make sure that that's always going to be fine, and it should be, because if SymConnect open does not succeed, then we're returning early, and we never create a SymConnect struct here. So that's something that we have to think about. Do we ever create a SymConnect struct when we shouldn't? And it looks fine here that we will only create this SymConnect struct if we have a successful call to SymConnect open, and that means we'll only call the SymConnect close if we have had a successful SymConnect open, which is exactly what we want. Great. And Dennis C is saying that it's looking pretty good over here, so that's good. So the next thing that we need to do is make these calls here, and let's take a little bit of time to figure out what's going on here. We're calling this map client event to sim event. So let's take a look at the docs to see what they say about that. So map client, the SymConnect map client event to SymConnect function associates a client defined event ID with a Prepara 3D event name. And we're on Prepara 3D. I think this is another. What is Prepara 3D? I'm looking at these docs and I don't even know what it's for SymConnect, which is used by multiple things. I don't even know. Something by Lockheed Martin. That's interesting. Yeah, it's a military simulator. Interesting. So we're looking at the docs for SymConnect that's used by this this military simulator, aviation simulator. And we're using it in a different game, but it should, in theory, all work because it's the same SDK. We'll see. So yeah, apparently we can associate a SymConnect client event ID, and I should make this bigger because you probably can't read this at all. Sorry for that. So it specifies the ID of the client event. So this seems to be, event ID. Interesting. Attach the client event. Okay, so interestingly, we pass in some kind of event ID, and then we pass in an event name, and that associates that event ID to that event name. Specifies the parameter event name, refer to the event ID's document for the list of event names. If the event name includes one or more periods, such as custom.event, then there are custom events specified by the client and will only be recognized by another client and not Prepara 3D. Okay. Since no Prepara, I wonder if this is the same for MSFS 2020. Maybe, presumably so. Alternatively, okay. So, so this is great. We have a way of associating events with particular real events. So presumably breaks is an event that MSFS 2020 understands. And if I remember correctly, we're doing breaks here as well. So breaks is something that MSFS 2020 hopefully understands, and we want to associate it with this event breaks, this event breaks thing that we're defining. Cool. And I mean, enums and C are just numbers at the end of the day, so presumably, let's go ahead and see what the header file gets translated to when we actually add this in our build.rs. We can go ahead and call this whitelist function thing here. And so now we should be generating this inside of our bindings.rs. Yes. Interesting. Okay. And here's the event ID, which is a type SymConnect client event ID, which itself is a D word, and a D word is a CU long, which a CU long is, I mean, we can just use that, but I think that's a U32. Cool. So now we need, this is where the real finesse of the whole thing comes in of FFI, is deciding how you want to actually expose these things. I think we're gonna, for now, since we're only 30 minutes left and we really wanted to try and do all of this, I don't think we'll quite get there. We're gonna punt on the question of how to expose this in a kind of idiomatic, beautiful Rust way, and we'll just kind of hack it in. So we can do something like fn associate breaks. We'll just hardcode breaks as the thing. And this is going to take a self here, and it's going to call bindings SymConnect map client event to sim event and pass in our handle here. And of course we got to pass it in as a raw pointer. And this is complaining that this is all horribly unsafe, which it is. I always like to do it like this. Let HR this. And now we need to pass in the event ID, which needs to be some number. And so we can do it how they did it in this example, where we create an enum event, and we'll call it breaks. And just to make sure, we'll say that this is going to be, so how enums are laid out in memory is kind of up to Rust, but we can specifically say, like, we want this to be represented as an unsigned 32-bit integer. So that Rust knows, okay, the event enum, I'm going to lay it out in memory just as I would lay out a U32 type. And that's exactly what map client event to sim event is expecting this client event ID type, which is a U32. I should make sure that it's a U32. What is this? This U long, I'm 99.999% sure it's a U32, but I just want to make sure. Clevin says this type will always be U32 or U64. Okay. Windows assumes U32. Okay. So this is good. We will only ever run this on Windows, and this when you hear about people talking about porting things between different platforms and stuff like that, especially around games and stuff, this is a big one right here. We're going to assume that this is a U32, and on Windows it should always be U32. So let event equal event breaks, and we're going to pass in the event here. The event and as a U32. And because we did repr U32, we can just use this as casting to cast it as a number. And then we need to pass in the event name. And if we look at the documentation, the event name is a const char star. And if we look in here, also it says a const cchar. So we need, presumably, again, a C string. So we can say C string is new here, and it's going to be breaks. It was all lowercase, right? Just making sure it's all lowercase. Yep, all lowercase. And since we know it doesn't contain any null characters, we can simply unwrap it. And we should be able to say name dot as pointer. And this should be fine. Name here, this C string will be dropped at the end of the function here, but presumably map client event to sim event doesn't need that name for longer than the call itself. It doesn't need ownership of it, so we should be fine here. Great. We probably want to return a results of nothing or an I32. So maybe we should come up at some point with a macro that does this kind of boilerplate for us. If HR does not equal 0, then return error HR. Otherwise, return OK with nothing in it. So this presumably associates the breaks event, this event up here, where did we put that? Right here, with the actual event breaks that hopefully the flight simulator understands and will do something about. So we should call that here sc.associateBreaks. And we can go ahead and unwrap for now. So let's go ahead and run that. I'm going to close this real quick. Cool. And we didn't panic or anything, so presumably that returned a 0, which is good to know. And now I'm wondering, so this code right here has to do with associating this input of shift control U with this event breaks, but these two lines here seem to be tied to this. So let's just do these real quick. So we need to add, this is add client event notification group. Let's take a look at that real quick. This is used to add an individual client-defined event to a notification group. We don't really know what notification groups are. Presumably they're important. I don't know. This sample does it, so we'll do it real quick. Did we already add that into our build.rs? No, we didn't. So we'll add this notification group thing, and for good measure, we'll just come in and do this group priority thing. So apparently there's notification groups of some sort, and then we can set priorities on those groups, presumably. And in the example here, yeah, they have this group ID thing. So we can just basically copy that as well. We'll just say that this is a group, and the first group is group 0. First and only group, group 0. So in here, we need to then call, here is a great sign. Let's go ahead and just add a macro real quick of macro rules success. And what we're going to be doing is this thing. So we need to take an HR. And HR, oh, come on, can't type. Let's get this out of the way. HR is an expression. This should work. And of course, macros have to be defined before they're used in the file. It's the one thing in Rust where the order in the file actually matters. Let's put that here. So could not find HR in the scope. There's HR. Is it, oh, this HR it means. Cool. Great. So now this macro basically expands out to this here, so we can use it over and over again, which is nice. We can even use it here. And in fact, we could just do success. And this is sort of what they're doing in the C code as well. Cool. In fact, let's do that here as well. Success. Oops. And then we can just, oh, what is it complaining about event here? Use of moved event. I mean, it's fine for us to. Ah, this is wrong. This is wrong. Wrong. We want this. This is very subtle, and we almost got caught by it. But when we do macros, we take this expression here and we kind of paste it in. And so we would have run whatever inside of our success macro twice. We would have had the call in here pasted in twice in here, which we do not want, right? We only want it to happen once. And so we can do it like this instead. And the Skeptical Potato, thank you very much for the follow. I appreciate it. So now we can do this instead. Hopefully that makes sense to everybody. Cool. And so now we can just basically do the same thing here, where we call SimConnect. Why is, oh, it's not. That is unfortunate. That Rust Analyzer can't really handle macros right now, and so it's not giving me the name of the function in autocomplete. So we can just copy it here. So what is it saying? Takes 4 arguments, which it certainly does. Those 4 arguments are the handle, the notification group ID, the event ID, and then maskable. I don't know what maskable is, but the others make sense. Let's do that real quick. So the handle, the group ID, which is just going to be group equals group 0, and then maskable. What is this? Doesn't even, oh, this doesn't even have it, which makes me think that it's probably in C++ default variable. So be maskable. True indicates that the event will be masked by this client and will not be transmitted to any more clients. False is the default. Okay, false is the default, so let's do false. Bool, if we look at what bool is a cint, and bool, and I want to say bool, false is, see. Yeah, tell me which one is true. I'm pretty, yeah, here it is. Microsoft specific, false is 0. So this is the other way around, where success was, and H result is 0, but here false is 0. So we can just do 0. What's it complaining about here? Complaining that event has been moved, which is true. event is moved up here, but we should not care about events being moved because they're just numbers. So let's derive copy here. And of course, we have to derive clone. So just real quick, for those that are not familiar, we're passing in event here into our function, and by default in Rust, variables are moved into their functions. So we move the variable event into here, and then we try to use it after it's been moved. We can't do that unless it's copy. So it has copy semantics instead of move semantics. So we derive copy. And in order to derive copy, you have to also derive clone. And that's fine to do because these are just numbers. So copying them is very, very cheap and probably what we want anyway. Okay, let's check that everything is good. And we're not using this yet, but we will do that in just a second. So everything seems to be fine. And let's just copy it real quick. So now we set the notification priority, presumably because each group can have a different priority. Makes sense to me. And this has 3 arguments, and they are the handle, the group ID, and the priority. Okay, so handle, group ID, and priority, and I don't know what the priority needs to be. So we should take a look here at this priority. SymConnect priorities. Oh, does it give us the priority? Let's see if it gives us the priority enums here, and it doesn't look like it does. In here, we don't seem, we should have it though, and I think we can come in here and do dot whitelist type. And I hope that this will give us hopefully this will give us that highest priority, because we only have one group, so the priority is, it doesn't look like it's giving it to us. But this is 1, so we can just, we'll just hard code 1 here. All right. So we are rapidly running out of time, but that's fine. It would be really great if we could try and do this real quick, where we actually call the dispatch. So we need this call dispatch, and this presumably hooks up a callback function to the kind of loop that we have. Call dispatch. Yeah, used to process the next SymConnect message received. Yeah, that makes sense. So we need to generate this here by adding it to our whitelist. And this is going to be a function. And then let's do this up here real quick. We're going to loop. We're going to call standard thread sleep for standard duration, or standard time duration from secs 1. So this is going to sleep every 1 second, just like they're doing over here in this example. And we're going to call this SymConnect call dispatch in here. And that hopefully should work. So we, in the call dispatch, we have to pass in this handle. So it's, right now we're just kind of really roughing through it just to get it to work. This is not going to be the most beautiful API, but that we can figure that out at a later point. So we're passing in the handle to it, and we have to pass in this proc. So this procedure that presumably has some kind of presumably we'll get a bunch of events in here. So let us oh, and it says an option, so we'll do some. Reason it's an option is because function pointers in C are pointers, right? They can be null or not, but in Rust they can't be null, and so you have to model them as options. And then this context, and they've put the context here as null. So we'll do the same thing. Standard pointer. And we give it a callback. And of course it doesn't know what that callback is, so we're gonna have to implement callback. Now it has this callback. I'm not exactly sure what callback is here. What does callback mean? It's defined as a standard call. Okay, so this has to have a standard call ABI. So that's extern standard. This is just the way that the function gets called. If you don't know about ABIs, don't worry about it for now. And it needs to take in the correct types of things. Whatever the SymConnect revc thing is, it's presumably a type that we'll need to add to our allow list. And then U32. So it's going to take, what do they call it? P data. We'll just call it data. And that is a pointer to this bindings SymConnect revc, which we've just added to our bindings. And it takes a CB data, which we can just call, I guess we'll have to call it CB data. Everything's data. CB data is a U32, or bindings dword is also fine. And P context, which is just a pointer to the void. And it needs to return void, which it should. So then we can just say print line called. So this should just get called when we get a callback. Why is this complaining? Oh, interesting. Unsafe, extern. Okay. Hopefully this doesn't matter. This is saying it is expecting a mute instead of a const pointer. This I'm worried about, because it's saying that it expects a C, but we've been told that this needs to be a standard call. We'll see if we run into anything weird. This may be an issue with bindgen. There, it doesn't understand that callback needs to be a standard call function, and instead it's just doing the C ABI here. We'll see what happens. This is getting kind of deep into the woods of understanding exactly what ABIs are being used and stuff like that. This is why FFI can get a little bit difficult at times, or challenging even in simple scenarios. But let's see if this works. So again, we're looping forever and just calling this sim connect call dispatch function just like they're doing here. So if we run this, called, cool. So our callback function got called. We don't know what it got called with. And let's see for the last 8 minutes of our stream today, if we can figure out how to take a look at that. So this dispatch procedure gets called here, and presumably by looking at this field DWID on SimConnect Rev. Let's look at the documentation real quick of SimConnect Rev C. No, that's not what we're looking for. Here it is. SimConnect Rev C. So it has 3 fields: DW size, the total size of the return structure in bytes; DW version is the version number of the SimConnect server; and DWID is the ID of the returned structure. And then that apparently is one of these things. Okay, so interesting. So it could be null, an exception, open, quit. We'll see what it returns to us. So let us simply print that out then, this DWID. So we want to dereference the data pointer here and get DWID. Oh, there we go. Called with 2. And here, 0, 1, 2. Okay, we got SimConnect Rev C, Res C, Rec V ID open, which makes sense, right? So presumably, I'm guessing that this gets called when the call to open, like it gets, there's some event that gets logged when we call SimConnect open, and we're receiving a callback for that here. Cool. And so we can simply now do what they're doing, where we say match against this ID. I'm pretty sure these take regexes, so we should be able to do any to get to add to our allow list anything that starts with SimConnect recv ID, and hopefully, let's see, rec. Awesome. So okay, cool. So we got all these things here. So now we can use these as, oh, and these are super long. Great. So these are all the things that we saw in this long list here of this enum, just as a const. So if it is not event file name, ID open, then we can print line open. We've gotten the open callback. Oh, it's just binding it. How do I do that where I wanna, do I have to do? That's a bit unfortunate. Oh. Found I32. Cool. And I think I can just, I should be able to just do this, because when it's a constant, should be able to do this. Oh, okay, that works. Cool. So now we get a callback when it's open. And what else are they looking for here? This ID event case. So bindings. So we should be able to match on that as well and say print line event. And we still need an else case here. Unrecognized DWID. And so we'll do that when we don't recognize the ID. All right. So we're reaching the end here. Let's actually open is called. Let's try and trigger this breaks event inside of our game. And I know you can't see the entire screen, but that should be fine. We're going to load her up and fly. Let's go in here. We'll fly from where is Tegel, which is my home airport, at least for a little while longer. And we're loading up here, and I'm just gonna real quick bring these up. You can see here my joystick, and I'm hoping that when we engage the brakes, we'll get a call back. We'll see. If not, we'll probably have to call it there anyway, unfortunately, because I gotta make dinner. So this game takes a little while to load. It's still loading. You might not be able to see it now, but it's the loading indicator is not fully through. Using Rust to control flight simulator. Yes, indeed. Yep, that's what we're working on. Hello, Eric. We're not quite controlling it yet. We're simply just getting information from it. That's what we're hoping to get done right now. We're at the end of the stream, unfortunately, but the hope is that we will get a call back when we break. And Teleball, thank you very much for the follow. I appreciate it. So hopefully, if this thing ever loads, and I probably should have picked somewhere out in the middle of nowhere, because the closer you are to a city, the longer the load times are. And especially my computer's probably struggling with streaming and everything. So the load times are a little bit longer. But the break button is mapped on this. Hopefully you can see this. The break button is mapped to the 4 button right here. All right, ready to fly. And I'm gonna hit the 4 button here, which engaged the parking brake. Oops. And event. And we can assume that that event is the brakes event. If it was something else, in fact, let's go ahead and start it up again. We get the open event, and then again I'll hit 4, 1, 2, 3, hit, and we got the event. So it seems to be working. We have events. Let me go ahead and put this down real quick. Stop tripping my. Uh-oh, I'm all tangled up now. Oh no, oh no. All right. So it seems we've got events working. I'm going to go ahead and commit this code and push it up to GitHub. And chat, if you can let me know what you thought of the stream today. If you enjoyed it, if you thought that this was entertaining, if so, we can go ahead and continue working on this together, and hopefully create a flight simulator SDK for Rust that is really awesome and allows us to do something more than just print out event every time we hit the break button. But that's basically it for me today. I hope y'all enjoyed the stream. Please like and subscribe and follow me on Twitch and on YouTube as well. You can find me under Ryan Levick on YouTube, and on Twitter Ryan_Levick as well. Let me know what you thought. I really appreciate it. And the more I know it's silly and stuff like that, but the more likes and subscribers that I get, the more it lets me know that people actually care about this stuff, and the more motivated I can be to actually produce it. So if you do like it, it really does help. It really does mean something. Please hit the subscribe button. I'm not doing this for money. I'm doing it for fun, but it does help me stay motivated. So I really appreciate it. Any support that you can give me. And with all of that, I wish you all a very happy weekend, and we'll see you next time around. So enjoy it, and hopefully see you in the skies as well. All right. Thank you very much.